Okay, Dan, you've got the rest of the time to do with what you will.
Excellent. Okay, everybody, hey, everyone. I'm Dan from the AI for Nature Society program at Google. I'm going to be talking about like 9 zillion projects in the next 14 minutes about computer vision for environmental monitoring.
Dan, you've got 18 minutes.
Even better, then I can talk about 11 zillion projects. So basically, I'm going to be throwing like a million links at you. And I want to encourage, rather than doing this in PowerPoint and trying to frantically dump all the links in the end, I want to encourage everybody to like click and explore the links while I'm talking and like pay attention to me when you feel like it and tune me out when you feel like it. So I'm going to put a link, instead of presenting from slides and present from this GitHub repo, I'm going to put a link to this GitHub repo in the chat and encourage you, like, think of me as your tour guide for this README file, and you can leave and rejoin the tour group whenever you feel like it. And I'll be a little bit disappointed if everybody actually pays attention to me the whole time. Lots of links to click. Okay, a couple of projects I'm not going to be talking about today that I want to call out because some of you folks know that I work with the bioacoustics folks here at Google. I work on the Wildlife Insights project. And if I talk about all these projects, and I don't talk about Wildlife Insights, you might think, Dan, don't you think Wildlife Insights is cool too? How come no love for Wildlife Insights? Au contraire, I want to use peer pressure to get my colleagues to come talk at future Wild Labs events. So everybody get on their case and get my bioacoustics friends, my Wildlife Insights friends, some of whom are there on this chat right now, to come talk at a Wild Labs event soon. That's the only reason I'm not going into depth on these projects.
Do you want to call some people out by name, Dan, that we should?
No, I want you, Steph, to call people out by name. You know who you are. Wildlife Insights friends and bioacoustics friends, you know who you are. Okay, so what I am going to be talking about today is our work on using aerial imagery and machine learning for urban forestry, some work with USGS and US Fish and Wildlife on finding geese in aerial images, and everyone who knows me knows I can't go 15 minutes without talking about camera traps, so I'll squeeze in some camera trap stuff at the end. Also, by the way, there's like a 0% chance I'm actually going to get to the end of this README file. That's another reason I'm doing it like this, is because there's lots of links, and whatever I don't get to, I'll stop at 9 o'clock, and you can all read the links at your own time. Okay, so let's talk about trees first, which is a little uncomfortable for me since I only ever talk about pictures of animals, but we're going to have to talk about pictures of trees for a few minutes because trees are important. In the lightning talk version of this, we're not going to get into all the benefits of urban trees, but if you like, don't overthink it. Mostly this work is about shade. There's lots of other benefits of trees, but with rising temperatures in cities, the number one reason that urban foresters do what they do is this is a climate adaptation project, and it's really important to provide shade in hot cities. So don't overthink it. It's great. What does this have to do with AI? I'm not here to tell you about trees. I only ever talk about AI. Lots of folks here work on wildlife monitoring. And so you must think those urban foresters sure have it good. They have to monitor these things that never move, and they're huge, and they're green, and they're bright, and you can see them from space. So that sounds really easy. But actually, getting a detailed understanding of a city's tree canopy is actually still a very expensive proposition. It usually involves putting a plane in the air and either capturing bespoke imagery or bespoke LiDAR. Some cities can't afford to do that. And understanding where your tree canopy, some trees are on public land, some trees are not, some you can see from the street, some you can't. So actually understanding where a city's tree canopy is super important, but still super expensive. I am not, of course, going to tell you that like AI to the rescue, AI can automate this, no one needs to take pictures of trees anymore, but the combination of imagery, AI, and imagery that's already out there really can help cities get started with urban forestry surveys for cities that haven't been doing detailed urban forestry inventories before, and can hopefully, even for cities with mature urban forestry programs, can hopefully reduce the time and cost of tree canopy assessments. So still, what does this have to do with Google? I work for Google. So when you go to Google Maps, you may take for granted that actually a super cool thing that Google has for sustainability applications is all that high-res imagery you see of cities all over the world. So Google has all this cool high-res imagery. Google does lots of AI. And so like way before I ever got to Google, Google was finding all kinds of things in that imagery that are important to Google business and Google products, like trees and roads. And trees just happen to be one of the things that long before I got here, Google was already finding in that imagery. And so still long before I got to Google, some Google folks figured out that said, hey, we're doing a pretty good job finding trees and all this imagery. And cities are spending lots of time and money trying to find their tree canopy. Maybe we can connect the dots and roller skating key and everybody can be happy. And so making a long story short, now you can find lots of tree canopy estimates for lots of cities within the Google Environmental Insights Explorer product. If you hear me say EIE, that's short for Environmental Insights Explorer, this is a whole bunch of different data feeds that Google makes available for urban sustainability. I'm only going to show you the trees, but I hope everybody is clicking along with me and going to go explore your own city and then ignore me for a few minutes. So I expect to be ignored. I could like Maybe I'll use lots of profanity in the next 5 minutes because I hope everybody's playing with EIE and ignoring me. But anyway, I'm going to go search for Bellevue. That's where I live. And if I click over here on trees, I see this pretty visualization of our estimated tree canopy for Bellevue. I see a citywide estimated tree canopy. If I click on, in the US, if I click on census tracts within Bellevue, I can get neighborhood level estimates of tree canopy. And I hope you're all now totally distracted by all these bright green pixels and clicking around on your own. So that app is kind of the foundation of what we're doing. That kind of gives you a feel for what the data is. And really I'm not going to talk about machine learning today. Really what I want to talk about is a couple of different ways we actually put that data to work for cities. There's basically 3 ways we take the output of that whole machine learning system and put it to work for cities. So one of them is the app I just showed you, the EIE app itself. So any of you have decision fatigue and couldn't decide what cities to search for, I've included some links to cities that look pretty in here for Zurich and Mexico City and Seattle. I had nothing to do with that front end, so I can say without being a total narcissist that I think it looks really good. And I think that's really important because actually the app itself is a really important communication tool for urban foresters for cities to get started who really have no idea of what their tree canopy is, but also for urban foresters to communicate with their citizens and for urban foresters to use this as a tool to communicate with their leadership, to communicate with the mayor's office and help allocate resources for tree canopy planning. So the app itself is part of how we put data to work. But it's definitely not the only way. Yeah.
Dan, can I ask a question from Rob? Can it measure tree cover loss or gain over time?
That's a really complicated answer for that.
Okay. So I shouldn't have interrupted.
No, it's fine. So we can generate this tree canopy estimate whenever imagery exists for cities. If you were collecting imagery for the purpose of tree canopy estimates, you would neatly fly over the whole city on a single day, every 2 years or something. You would do a very structured survey. That's not what this is. These pictures are taken for Google Maps, and they're taken whenever they're taken, and you might get part of a city 1 year and then a different part of the city 3 years later. So you can combine them, but you're sort of operating out of spec in the sense that, so for some cities, for really large cities, we have so much imagery that you really can put together a meaningful time series. For other cities, it's a little more complicated. So the answer is kind of sort of in some places.
Interesting. Cool.
So the app itself is an important part of what we do. Another part of what we do is there's a little link on the left side of that app. If you look carefully, there's a little link that says submit an application to get high resolution data for your city. If you are an urban forester working for a city, knowing, Google thinks this pixel is a tree and this pixel is not a tree is great, but to do any meaningful planning or analysis, you need to now overlay that with all kinds of data that only the city has. You need to know which land is public and which is private, and where can we fit a truck to plant trees, and where are the irrigation lines, all of those things that exist only within a city's GIS environment. So we do want to be able to provide that high resolution data to cities, but meet them where they're at so they can use it in their environment with all the data they have. So cities that fill out that link, that goes to a Google form. That Google form goes to me. This is one of the most fun parts of my job now. I get to now prepare data and work with urban foresters all over the world. And we try to meet them where they're at, depending on the environment they're working in. So some cities are working with Google Earth Engine. So here's a screenshot from somewhere in Edinburgh, that what you would get from us if you were working in Earth Engine. If that same city was working in other GIS environments, we might just send them GeoTIFF. So here's the same data, give or take, viewed in QGIS. So this really direct delivery of data to cities so they can work with it in their own environments is another important part of how we do what we do. And then lastly, we also provide data in a bunch of different shapes to impact partners. And in particular, we've shared a whole bunch of data with American Forests to support their tree equity score platform. And maybe if you get distracted by one link in this entire talk and totally ignore me for a while, go check out the tree equity score platform. It really is amazing. They're doing amazing work all over the US and soon expanding outside the US to help cities understand and mitigate social inequity in access to trees and green spaces. It's a really amazing platform. And so we're able to give them a whole bunch of data to scale their platform to places they didn't have data before and make it more accurate even where they did have data, because they were dependent on public 30-meter resolution data before. And so that sort of exists outside our direct relationship with cities and outside the app itself is working with partners like American Forests. And so if you work with urban foresters or city planners who might benefit from this kind of data, please encourage them to click that link. Encourage them to click that link, even if there's no tree data for their city in the EIE app right now. There's a million reasons why we might be able to provide data for a city, but they might not appear in the app. So, okay, so that is as long as I can go without talking about pictures of animals. So let's talk about pictures of animals, because that's what I like to do. In fact, specifically, let's talk about this little guy right here. This is a brant goose. The brant goose is distributed all over the northern hemisphere, but has a possibly declining population in the western US and Canada. This is an airplane. You can put cameras on the bottom of it, and that's exactly what USGS and US Fish and Wildlife do to survey this brant goose population. They congregate at this particular lagoon in Alaska, and so every year, USGS captures about 130,000 high-res images that look something like this. All of those little dots are in this image are brant geese. About 95% of the images they collect don't have any birds at all. You just have to believe me that there's no birds in this image. And brant are not the only bird in this area. So this image, again, you just have to believe me, has 4 different species of bird in it. So if you zoom way in, you can see there's these little brown fuzzy dots and these little slightly white fuzzy dots. Those are different species of geese. That's a brant and that's a Canada goose. And so they image around 100,000 brant every year, and then another 25,000 examples of other species. Counting all those is not only tedious. Counting all those would likely be prohibitive for continuing this monitoring program. It's was still kind of experimental, and this really was like, if we had to keep counting 100,000 birds manually, that was going to be a non-starter for me able to continue to do diligent monitoring of this species. And so I got connected to USGS, who had done an amazing job curating a really large data set with the help of this other no-code tool, Count Things, that like did a pretty good job, but not perfect. And they took the output from that system, did a ton of data curation. Once in a while, if you're a machine learning person, you stumble upon this magical gold mine of a data set that's huge, and somebody still cares about it, and it's really well curated. This almost never happens, but I just like walked into this amazing gold mine of data. So USGS had put over 400,000 training points on brant and about another 60,000 training points on other species. And now you can basically imagine what's going to happen from here. The goal here was to train a model to get them out of the business of counting 100,000 geese every year, so that this monitoring program could continue to be run annually and continue to be maintainable. There's not a lot of like fancy deep learning to tell you about. We trained a YOLO v5 model, basically using off-the-shelf hyperparameters. The model, those images that you saw before, those are massive. They're like 8,000 by 7,000 or something. So that is not the atom on which the model runs. The model runs on little 1280 by 1280 patches that look kind of like this one. And because this is a lightning talk, I'm also not going to get into lots of detailed results with precision numerical graphs. There's only one result I care about, and that is, is the ecologist sufficiently happy with the results that they're not going to count 100,000 geese next year? And so to that, so far, the result seems to be an emphatic yes, starting with 2022 data that they've already collected. Again, I always caution, if I ever tell you that AI can completely automate anything, I owe everyone a granola bar. So I'm not going to tell you that AI can completely automate this, but the intention now is, for starting with the 2022 data that's already in hand, they will review between 5 and 10% of the total images, just to basically make sure that the model hasn't gone totally off the rails over time. And that we really believe that's the difference between this program being scalable and the program not being scalable. So I'm very happy with that. And you can click through for code. We've made the data publicly available. We're also working, this species also exists here in Washington, and Washington Fish and Wildlife does very similar flights to survey the species in Washington. So some of the work we're doing now is to try to adapt this model to work well in Washington. You can read all about it at the GitHub repo and check out the data. I'll say this really is just one of a million projects like this right now happening on AI tools for aerial and drone wildlife surveys. I think this field really is at an exciting inflection point right now, kind of where AI for camera traps was a few years ago. So there's lots of global data out there. There's starting to be some global models out there. So a bunch of us kind of got together and curated all of the public data sets that we're aware of into, I won't say into a common format, but like very close to that with some common metadata. So I'm telling you that, so go click that link if you're interested, play around with some public data sets, but also this little community effort of like dividing up the work of getting all those data sets into a common format, that was actually, I think, more successful than I thought it would be and super fun. So I encourage everybody to do that for other domains. Even before I knew what today's talks were, I swear I did not plant this just for today's talk. I actually think marine video is at like a similar inflection point where there's starting to be some public data out there and a clear need for AI. So I hope somebody goes and nudge everybody on this call. I hope somebody goes and like organizes one of these community efforts to curate all the public marine video data that's out there. Okay, and now that was a record amount of time for me to talk without saying the word camera trap. So now let's close with just a little bit about camera traps. I swear I'm not going to try to get through all of this. I know we're getting close to 9 o'clock. Do a couple updates on, in fact, the only thing I'll do now is a couple updates on megadetector. So for those of you who are not familiar with megadetector, this is an object detection model that finds animals, people, and vehicles in camera trap images like this one. In practice, even though it's an object detector, we really use it as an image classifier. We use it to classify images that are animal, person, vehicle, or empty. And really, most of what it gets used for is to help get ecologists out of the business of looking at empty images. We're currently at version 5 of megadetector that was trained in 2021 and released in 2022. Some of you Wild Labs veterans may remember that CU talked about megadetector version 4 at a Wild Labs event a long time ago. So the whole point of what I want to say now is I'm going to say none of what CU said. It's a great talk. Go watch it. It's all still sensible. I just want to summarize very quickly what's happened since CU last talked at a Wild Labs event. And so the biggest thing that's really happened since then is the release of megadetector v5 in 2022. This was a switch to YOLO v5, which we did some things to expand the training data and make it work better on some things that megadetector 4 really had trouble with, especially images like this where animals overlapped with man-made objects. These just drove megadetector 4 crazy. So there's that. But also the switch to YOLO v5 just made megadetector 5 a lot faster than megadetector 4. I had underestimated how important this was. I'm so glad that like CU was right and I was wrong, and she was like, "Oh, this is really worth this big architectural change, like high-risk architectural change. People are going to care that it's faster." The change in speed really has allowed adoption of megadetector to grow a lot, and so I'm super glad that CU was right and I was wrong. And so, in addition to the release of megadetector v5, the thing I'm most excited about in the last year and a half or so is this just amazing ecosystem of collaborators and other tools that use megadetector that have grown up that really have turned this into a community project. We released a pile of bits and everybody else did all kinds of things to make it useful. I'm not going to go through all these, but what I've included here is a bunch of pretty screenshots, including one of my dog. There's Willow. Hi, Willow. Including one of my dog that just showing some of the tools that are out there putting megadetector to work. Some of you who maintain these tools, like I saw Peter's here. This is Peter's tool, EcoAssist, that helps users run megadetector. A whole bunch of tools that help people run megadetector or use megadetector results or work with megadetector in online platforms that just like have really scaled way beyond what just we as model developers could do. So super thrilled to see all this over the last couple of years. And then lastly, in my little corner of the universe, so all that's happening, it's great. Although the model weights haven't changed since the release of megadetector 5, a couple neat things that we're working on to make megadetector better without actually changing the model weights. A couple areas we're focused on are one, as long as animals continue to try to look like rocks and sticks, sometimes you're going to pick up rocks and sticks and megadetector is going to think they're animals. No amount of retraining is going to make that totally go away because animals are literally trying to look like rocks and sticks. We've made some significant improvements to the tools we use to help people get rid of all those rock and sticks that don't move like animals do. So that's one thing. We have recently added support for YOLO v5's test time augmentation, which I know now this is like the most technical nitty-gritty thing I'll talk about today, but like this is as close to a free lunch as exists in machine learning. You let inference run a little bit longer and magic happens, and you can find some things that megadetector previously failed to find. I showed this example here because this is a grouse. This user is doing a survey just to find grouse, and megadetector, this is not the easiest or the hardest thing in the world, but megadetector was not doing great. It was missing more of these than we would have liked. This is a case where the test time augmentation built into YOLO v5 really did some magic and helped us find a whole bunch of these grouse that was missing and got this user out of the business of manually reviewing 3 million images. So I encourage everybody who's using megadetector to go tinker with this test time augmentation tools. And we're right at time now, so I will now stop.
Okay.
Lots more links. Yeah.
Did you get through everything, Dan?
I promised I wouldn't.
Okay, everyone, there's more to explore. Your tour guide is checked out, but that was like an awesome sprint through some really cool stuff. I think half of us are still back on the trees. So thank you for sharing that. I wonder, Dan, what's the one thing you're most excited about that you're working on right now?
You totally just given me an excuse to just like add to more of the stuff that I didn't get to at the end. Right now, what I'm really excited about. So in these cases where megadetector, I am obsessed with cases where megadetector doesn't work. I love it when people send me examples of megadetector not working. And there's no perfect fix for that. Like other than having all the training data in the universe, you'll always find things that it struggles on. So really trying to build up a workflow for taking the cases where it doesn't work and fine-tuning it to build like a little fork of megadetector that works a little better on this thing that was previously failing, probably a little worse on everything else, and that's okay. And in particular, doing this right now for reptiles and sometimes for rodents, that's kind of Maybe I'm giving this answer because my head was in camera traps at the end of the talk just now. So, but in the camera trap universe, that's the thing I'm most excited about right now is trying to make it so that like Megadata doesn't have to work on everything. You can quickly fine tune it into working better on the things that it was previously failing on, especially reptiles.
How did people work with you? Because I know previously there was a whole program that helped people connect, but how does Google find new projects to work on?
That is a very broad question. There's definitely different answers for these. I mean, like, I should say the common thread in all of the conservation projects, I'd say this is true at Google, Microsoft too. It's not like we're a 500-person team and we're like, just email us. It's not like we come to Wild Labs talks. That's the best answer. Like, just email us. It's not like we're a 500-person team working on bioacoustics or camera traps. Everything is a little bit grassroots. So it's not like you have to like call the Google support number to get in touch with me. I'm here to learn from all of you on what we should be working on.
Okay, and one last question from Rob. Rob, do you want to ask it? I'll give you the floor. Since it's like 3 a.m.
Hi, Dan. I just had a very quick question. Somebody was asking me the other day about how long it would take for a complete novice with no, working knowledge of AI or megadetector or anything to be sent the link to get started with their data set. Roughly how long in your experience would it take now for somebody to get to a point where their data is getting processed?
To run megadetector on their data.
Yeah.
I mean, there's two questions buried in there. There's like how long to kind of learn what to do, and then how long to literally run it. I'll answer about this. For novices that are just getting started now, I do encourage people to check out EcoAssist. I think Peter's on this call who maintains EcoAssist. EcoAssist is a GUI that helps people run megadetector, and you don't need to. So our standard instructions use the command line, and I'm proud that I believe I have a 100% success rate in coaching ecologists through using the Python command line. You don't have to know how to write code, but I understand that's not the most straightforward way, and sometimes it does take a couple emails. So now increasingly I encourage people to start with one of the GUI-based tools for doing that. And I think that part will be very quick now. I think we're getting to the point where it's like you pretty much drag and drop into a GUI. It's pretty close to that. The question of how long it takes to run your images, a good ballpark is if you don't have an NVIDIA GPU on your machine, you can process about somewhere between 25 and 50,000 images a day through megadetector version 5. So depending on how many images you have, like probably a long weekend gets through like all your images for a year, maybe. It depends. If you have an NVIDIA GPU, it's anywhere between 200,000 and a million images per day you can probably process.
Thanks.
Did that answer your questions?
Yeah, perfect.
Awesome.
Hi, Peter.
Thank you so much, Dan. As always, I reckon you're probably going to be here for the after show. So if you're on the call right now, please hang out if you would like. We just generally have a more casual chat with folks in our community for the next half hour or so. But everyone else on the recording, lovely to see you. We'll see you again in a month. And thank you to all our wonderful speakers this month, this session. And we'll see you next month. Bye, everyone.